force of 5 newtons onto a 1 kilogram book at rest on the table. With what additional force do I need to press onto the side of the book to make the book move at constant speed? Mu equals 0.2.
Okay, this is number 7. We want to start with a free body diagram in this question. In this free body diagram, we can start with I lift upward with a force of 5 newtons. So there is an applied force up of 5 newtons. We also know that the mass of this book is 1 kilogram. In the free body diagram, we will have an opposite force of gravity that is pointed down. From your equation sheet, you know that force of gravity is equal to mass times the acceleration due to gravity. We know g is equal to 10 meters per second squared. That's the acceleration due to gravity, rounded from 9.81. And if we plug that in, Fg is equal to 1 kilogram times 10 meters per second squared, which gives us a force of 10 Newton. So the most important part of this question is, what is the normal force? We know that if the book is at rest on the table, there has to be a second normal force, this Fn. The key here is knowing that if you lift up on a book, but you don't lift up with more than the force of gravity, the book is still on the table. It just gets lighter. It just gets lighter. So your FAPP lessens the normal force by 5. It should be 10. But since you have an applied force up, your normal force will also be 5 newtons. If you see, 5 newtons plus 5 newtons equals 10 newtons, and that equals the force of gravity, because we know that the book is still at rest. The question asks, with what additional force do I need to press onto the side of the book to make it move at a constant speed? If I'm moving the book to the side, there will be an applied force, and there will also be a force of friction. The question asks, how do I move it at constant speed? That means our right force and left force have to be equal. So FAPP is equal to the force of friction. In that case, we will have to use another given, which is the coefficient of friction is equal to 0.2. And if we are looking for the force of friction, which is also the applied force, to get to constant velocity, we'll use the force of friction is equal to the coefficient of friction times the normal force, which gives us 0.2 times 5 newtons, which is equal to 1 newton. If that's the force of friction, it also must equal the applied force, and that will take it and move the book at constant velocity.